Okay, welcome back. I just want to say a couple of quick things about intrinsic threats to internal validity. And let's go through the list here. The first threat that I want to discuss is what's called a history threat. Now, this means that during the course of an experiment, life continues to go on in the outside world. So individuals who are participating in the experiment may learn things, they may be exposed to different things in their environment that may lead to a change in the dependent variable apart from the introduction of the independent variable. So, for example, if you can imagine an experiment that wants to measure the growth of feelings of empathy towards immigrants, and that the experiment shows videos about, or documentaries, about the conditions of life that people had to experience in the countries from which they are emigrating, and at the same time that this experiment is going on, these people have other events in their lives that would also lead to an increase in empathy, then what is responsible for the change in the dependent variable here, or for the growth in empathy? Is it the independent variable, the treatment of the documentaries that were shown as part of the experiment, or is it these other events that happened outside in their life? So you could imagine different cases where this could occur, but one thing that is likely to be the case is that the longer the time between the pre-test and the post-test, in other words, the longer the duration of the experiment, the greater the opportunity for some factor other than the independent variable to be a competing explanation for the dependent variable. So another problem is familiarity with the test instrument. Experimental subjects take a pretest in many of the experimental designs. If they take a pretest, then they become familiar with the test, and perhaps just that familiarity could lead to a different response, an improved response, perhaps in the variable of interest, and not some actual real change due to the introduction of the independent variable. So that's a problem that could happen. And if you were to change the test, that's actually another problem that we're going to talk about here in just a second. So to review, familiarity with the test instrument simply refers to improved responses that would not be attributable to the introduction of the independent variable, but to familiarity with the test itself. Maturation, this also can be a particular problem, generally with younger respondents, for which you'd have to get appropriate IRB approval, and it's usually a little more rigorous when it has to deal with younger respondents, but that they may mature between the time of the pretest and the post-test. So that's another issue. Now, the regression artifact is not dealing with statistical techniques such as regression, but it means that people who get an initially very high score or a very low score on a pretest will tend to score closer to the average in the follow-up test. And thus, the change is a mathematical artifact of moving from an extreme score to a more average score, and not actually due to the introduction of the independent variable. So think about it. You can have a very extreme score because you didn't get any sleep the night before your pretest and did exceptionally poorly, or something of that occasion, and then if you were to take the same test again, even though nothing has changed, you would do much better. So that's the idea of the regression artifact. Now, there can be some other problems with intrinsic validity in experiments, and those have to do with what we call experimental mortality or attrition, people dropping out of the experiment as it goes on. The experiment goes on for a longer time period, it's a greater risk, and that can certainly bias the results. So, to be careful, good researchers report the results only for those participants who completed the entire study and discuss any potential impacts on the validity of the study in their paper or in the write-up of the research. Instrumentation threats is a threat that I alluded to earlier. It happens if I see that there's some kind of problem with the pretest, so I change the wording between the pretest and the post-test. Now, is the improved response due to the introduction of the dependent variable, or is it due to the changing of the wording? So when you do experiments, just like if you do a longitudinal survey, you don't want to mess with your wording. And if you improve the wording, well, then that's a whole other experiment. This is why you want to be careful in the initial wording and make sure that everything is set to go before you actually go forward and do the experiment. One reason why we oftentimes will use pilot studies or a pilot experiment before we do the actual experiment. A couple of other things that you can read through here. Selective history is, when the control group and the experimental groups come from different geographical areas, and so they may be impacted differently because of things that are happening in those particular demographic areas and not the study themselves, or not the independent variable. Again, potential things that could account for variation in what you're interested in that are competing explanations to your independent variable which you're testing. The last threat I want to mention is selective maturation, and this is just when members of the control group and experimental group mature at different rates, and this can reflect sex imbalances between the groups or age imbalances between the groups, so you want to be careful for that. Now, this leads us to the solution here, and that is experiments have strong internal validity because they use control groups. Control groups allow us to control for so many of these threats in addition to spuriousness. So the control group helps to control for history threats, instrumentation threats, test familiarity threats, regression towards the mean, and changes in the instrument would actually affect both groups equally, although still unadvisable to do that. Thus, many intrinsic threats are controlled just simply by using a good experimental design. And this is why experimental designs tend to be considered the golden standard of internal validity. Finally, if we want to maximize both intrinsic and extrinsic threats, then we can use random precision frequency distribution selection processes that for both the control and experimental groups. So we can control both the internal and the intrinsic and the extrinsic threats to validity by following some of the good advice that is here. Thank you.